This is 6.2, adding and subtracting rational expressions. So I'm going to do a couple examples. I'm going to do number 2. The first thing when we're adding or subtracting, remember we want a common denominator. So we're going to rewrite number 2, and we want to factor if possible. And so we know that these two are common denominators, so we really don't need to change anything. So I'm going to write as one fraction. I'm going to go ahead and factor this. This becomes x minus 4 times x plus 4 because this is the difference of two perfect squares. So they're both common. This is what they factor to. I write it once. And then I simply do x minus 4. So I say x minus 4 because of that minus. And then this is where we bring in what we learn in simplifying expressions. We can simplify the x minus 4, and that leaves us with the final answer of 1 over x plus 4. So we'll skip down. This is just finding a common denominator. You'll see what I do in 8 and 9. So problem 8, again, we factor if necessary. I'll go ahead and highlight what we need to factor. So that's what we need to factor right here. What I do is I still, when I start off, write two fractions, and I write anything that does not need to be changed or factored. Okay, so those three things don't need to be factored. I can take a GCF of 3 out of this, and that becomes 3 times the quantity of x plus 3. Okay, and so now I need to make a common denominator. So what I look at is I look at both fractions and I ask myself what's already common. The things that are already common is this factor of x plus 3. So I don't need to change anything in that aspect. What I do need to change though is the thing that's not common. There's a 3 over here and there's not 1 over here. So I am going to take that 3 and I'm also going to multiply it to this side so that now they share that factor of 3. So now my denominators, is a common denominator. If I multiply this denominator by 3, then I also have to multiply its numerator by 3. And so this is how we get a common denominator. Once you have a common denominator, so I underlined everything that is common in both, so you see everything's underlined, then now I can write as one fraction. I take my common denominator and I write it one time, because now they're going to share that, and then I simply do the top operation. So I say 8, so I rewrite 8 plus, so I have a plus, and then I have 2x times 3, which gives me 6x. Okay, and so then I look and I see, so can I simplify any more? The answer is yes. I can factor this top out again. So again, now I look to simplify anything. So I go ahead and nothing changes to the bottom. I factor out 2 out of this, and this gives me 4 plus 3x. And so when I look at this, I still can't simplify anything. So this is my final answer. With number 9, we now have a subtraction sign. Okay, so again, what I look for is getting common denominators. Before I can do that, I have to factor these two denominators. So again, I go ahead and write two fractions. I leave quite a bit of room, and I write everything that doesn't need to be changed. So those are the both numerators. So I factor this trinomial right here. It gives me a factor of x plus 2 times x plus 3. When I factor this over here, it gives me x plus 2 times x plus 2. Okay, again, I'm looking for a common denominator. So I look to see what is already common if there's anything shared. And there is one factor of x plus 2. Okay, so what is unshared or uncommon is this x plus 2 needs another x plus 2 over here. So to make this common, I simply multiply x plus 2 to this side as well. So now this other factor of x plus 2 is now common. And so I multiplied to the denominator. That means I need to multiply to the numerator as well in the first fraction. I look at my denominators again. I still have a factor of x plus 3 that is not common. So then to make that common, I multiply this fraction by x plus 3. Okay, again, I underline just to show that now I do in fact have everything underlined. It is a common factor. Again, I multiply to the denominator, so I need to multiply that as well to the numerator. All right, and so then now I can write as one fraction, okay, with my common denominator. Again, the order doesn't really matter. And then what I need to do is I need to go ahead and distribute this right here. So this gives me x times x is x squared, x times 2 is 2x. So then I can go ahead and write that in my numerator here. And then I have to distribute this, okay? And you can see this one of two ways. 2 times x gives me 2x. 2 times 3 gives me 6. Okay, I haven't put the signs because I want to tell you about this negative. So we can go ahead and do our multiplication right here. We have a positive 2x and a positive 6. And then what we would have to do is distribute this negative to all terms right here. So that would make that a negative 2x and a negative 6. Okay, so you could do it that way. Or you could simply say negative 2 times x gives me negative 2x, and negative 2 times positive 3 gives me negative 6. Okay, but this is a common mistake. If you have subtraction, you need to distribute that negative to all terms over here as well. So then I simply write those down here, and then I just combine like terms. So my two like terms are right here in the middle. So my final answer is going to be x squared minus 6 over this common denominator. We can simplify the denominator to have the factor of x plus 2 squared times x plus 3. On the back side, I'm going to work out number 12. Okay, so again, I need to create a common denominator. So get my two fractions. This is a subtraction one again, and nothing needs to be factored, so I basically rewrite everything. Okay, and now this is where I create a common denominator. There's nothing common right now, so to make this common, okay, I take this x plus 1 and I multiply it to this side. What I do to the bottom, I do to the top. Those two are now common. Then, okay, this is what's uncommon, so I also multiply x minus 1 to the right side, and I do that to the top as well. So as you can see, I underlined everything that's common in the denominator, so now we have common denominators. So this step I write as one fraction with my common denominator, and then I go ahead and I start FOILing this out. I have x times x gives me x squared, x times 1 gives me 1x, 2 times x is 2x, 2 times 1 is a positive 1. Okay, I go ahead and combine these like terms, so this will simplify to x squared plus 3x plus 1. Okay, and then I do the same over here. I can FOIL this out. X times x is x squared. X times negative 1 is negative x. Negative 3 times x is negative 3x. Negative 3 times 1 gives me a positive 3. Again, this is subtraction, so I need to distribute that to every term over here. Okay, so what does that do to every term? It makes this negative plus plus negative. So then when I simplify this, this becomes a minus x squared plus x, and plus 3x gives me a plus 4x, and then I have my minus 3. Okay, because I combine those two like terms. And then right here, I do have more like terms, so I go ahead and combine those. X squared and negative x squared cancel. Okay, 3x and 4x gives me 7x, and then a plus 1 and negative 3 gives me minus 2. And then it's over my common denominator. And here I can't factor anything else out, so this is my simplified answer. Okay, I'll go ahead and do one more, number 13. So again, this one's addition. So I make my fractions. The numerators, actually, I'd concentrate on the denominators first, I guess. And so the numerators we don't need to do anything to those just yet. I want to find a common denominator. This one's the difference of squares, x minus 1 times x plus 1. Over here we have x plus 1 times x plus 1. To find a common denominator, what's shared already is one of those factors with one of those factors. So I want to make this common. I multiply x minus 1 to both sides. That is now common. I do the same thing over here for x plus 1. Those are now common. Now I have common denominators. So I go ahead, write one long fraction, x plus 1 times x plus 1 times x minus 1. I go ahead and FOIL this out right here. This becomes 3x squared minus 3x plus 3x minus 3. When I combine the two middle terms, they cancel, so I'm left with 3x squared minus 3. And then I do the same thing over here. X times x is x squared plus x minus 1. When I FOIL out, these two cancel again, so I'm left with plus x squared minus 1. And then I go ahead and combine like terms. I have two like terms here. I have those two, so this leaves me with 4x squared minus 4 over x plus 1 times x plus 1 times x minus 1. I can factor this numerator. So when I factor this, okay, I'm going to kind of factor it over here to the side. It gives me 4 times x squared minus 1. I notice I can factor this out again, so this gives me 4 times x minus 1 times x plus 1, because that's the difference of squares. So this is my new numerator. So I have 4 times x minus 1 times x plus 1 over x plus 1 times x plus 1 times x minus 1. And now I can simplify. Those two simplify, those two simplify, so I'm left with a final answer of 4 over x plus 1. So this problem was one of the harder ones because it incorporates our addition, and then we had to simplify this fraction after we were done with that.